Hello, everyone. The success criteria for this video is to reduce a radical expression that involves the operation of multiplication. So we will be taking two radicals, square roots and cube roots mainly, multiplying them together and reducing their answers. Okay. So I have a few examples kind of set up for us. First, I just want to kind of review how multiplication works. If I were to multiply two terms together, especially with coefficients and variables, I would take this and I would say, oops, let's get rid of that. I would multiply the 4. See if I can write here. There we go. Okay. I would multiply the 4 and the 6 together, and I would multiply the x and the x together. So that would ultimately just give me a 24x squared. I think you guys have all seen that before. Now, the way that this works with radicals is the same way. The coefficients get multiplied together and the radicals get multiplied together. Now, this is very, very different than how we did addition or subtraction. So if I were to do this problem, I would multiply the 7 and the 3 together, and then I would have a radical of the 2 and the 5, right? And we're going to use the operation of multiplication. So my answer ends up becoming 21 square root of 10. Now, one thing that we do have to watch out for is we're going to have to look to reduce this. You know, if I break this 10 down to 5 and 2, I don't think I could break that down any further. So since I can't reduce it, since I can't extract any perfect squares, I know that that would be my final answer. But for every problem that we do for radicals, not only are we going to have to multiply them together, but we're going to have to reduce that final answer as well. That can get a little tedious. So let's take a look at some kind of building questions here. They'll get progressively more difficult as we go. So example 1 is very similar to that of the one I did at the top of the page. I'm going to start. I'm going to multiply the 7 and the 2 together on the outside. Okay, I'm going to change colors so we can follow here. And then inside my radical, I'm going to have an 8 times 45. Okay, which means on the outside, I have a 14. And then on the inside, I have the square root. Now, I really don't want to multiply 8 times 45 if I don't have to. What I'm actually going to do is I'm going to try to break this down. I'm going to try to break this down into its smallest values to see if anything reduces here. So the 8, I'm going to keep breaking down to 4 and 2, right? 2, 2, and 2. The 45 is 9 and 5, or 3, 3, and 5, right? So if I have this, let's see what we can pull out. Now, there is already a 14 in front. So let's see if we have to multiply that 14 by any values. So because it's a square root, I can take a 2 out. I can also take a 3 out. Now, I'm going to write exactly what this is going to look like. I could take a 2 out. I could take a 3 out. But inside is still going to be a 2 and a 5. So again, you can use a calculator for this. You don't have to do this all mental math. But if I did 14 times 2 times 3, what am I going to get there? I'm going to get, I believe, an 84. And then on the inside, I'll just have a square root of 10. And that would be my answer. So it's one thing to multiply the pieces together, but then inside the radical, the blue part, we have to break that down. We have to reduce that radical into its smallest pieces, okay? Now, I can already see I made a little typo on number 2, so I'm going to fix that right away. And this shouldn't be addition. This should be a multiplication, right? We want to multiply. That's what this video is about. We want to multiply radicals together. And what I want to do is set it up the same way. So I'm going to say 2 times the 3 is going to be on the outside. And then on the inside, we're going to have the cube root. Now be careful because we're working with cube roots of a negative 10 times 12. Okay. Now I am going to break those down the same way that I broke them down before. I will have on the outside a 6. And then on the inside, let's see what this becomes. If I have negative 10, that's negative 5 times 2. Can't really break that down any further. I am going to take out the negative. We'll talk about that in a minute. 12 is 4 times 3, or 2 times 2 times 3, right? So I have a whole slew of numbers here. Now, this is a cube root, and on the outside of that cube root, there's already a 6. So do I have 3 of a particular value that I might be able to pull out? And actually, I do. I have 3 2s. Okay, so I'll pull a 2 out from that radical. And actually, the cube root, we talked about in a previous video, the cube root of a negative 1 is still negative 1. So what I'm going to get on the outside is I'm going to get a 6, which was already there, times a negative 1 times a 3. So that's all on the outside. And then on the inside, I'm going to have a 5 and a 3. So I'm going to get an answer of a negative 18. So if you multiply all that together, it's a negative 18. And then I'm going to have times the cube root of 5 times 3, which is 15. This would be my answer in radical form. So one, I'm going to look to see that you guys can multiply these two radicals together, that you can get to that step. The second thing I'm going to do is to see, can you actually reduce that answer into its lowest terms? Okay, so now example 3, I try to vary these up, try to make them all look a little different. I kind of made this like a distribution problem, okay, where we're going to take this 5 root 3 and we are going to distribute that into this grouping. Now, if we do that, I'm just going to multiply the outsides together and the insides together, right? So if I multiply 5 root 3 times 2 root 15, that's going to give me a 10 square root 45. Now, for the second one, if I do the same thing, 5 root 3 times 6 root 7 is going to give me a 30, because 5 times a 6 is 30, and the inside would be a 21. All right, now we have to look to see if this reduces. So I'm dealing with square roots here. 45 is 9 times 5, or 3 times 3 times 5. Okay, and I think because this is a square root, I can take a 3 out. So what I get on the outside is I have a 10, I'm going to have a 3, and inside I'm still going to have a 5. So this first radical is 30 square root 5 plus, now let's see what happens if I try to reduce the second one. 21 is 7 times 3, and actually I don't think I can break that down any further. 7 times 3 are 7 and 3 are both prime. There aren't 2 of any particular value, so it doesn't do me any good to reduce it. So this radical would stay 30 square root 21. Now, because those are not like terms, okay, you cannot add them together. We did that in a previous video. You can only add together radicals that have the same inside, the same radicand. Since the 5 and the 21 are not the same, you cannot add those together. That would be your final answer. Okay. I have 2 more examples here. Okay. Now I start to introduce some variables. Don't get afraid. We're going to do everything the same way. I'm going to show you how this works. So I'm going to set it up the same way I did all the other ones. I'm going to do a 3x times a 4x cubed. So the coefficients in front of each of those radicals are going to get multiplied together. And then the inside, I'm going to have a 2x cubed times a 6x squared. Okay, now we can start to combine some stuff together here. I have a 12x to the 4th on the outside, and on the inside, I have a 12x to the 5th. Now, what I want to do is I want to break this down. I want to reduce it. So the first step is, do you know how to multiply 2 radicals together? So if you can do this, you're on the right track. The second step is, now how good are we at reducing? So I want to break this down into 4 and 3, or you can use 6 and 2 if you want to, but I want to break it all the way down. Let's see if we can get, okay, times 3, right? So 2 times 2 times 3, and then I have 5 x's, right? And I have on the outside is still this 12x to the fourth. Now, because it's a square root, I want to circle my groups of 2. So I can take a 2 out, I can take an x out, I can take an x out. Now, anything that comes out is going to get multiplied into the front there. So what I'm going to get, if I take another 2 out, instead of 12 being in the front, I'm now going to have a 24. And there were 4 x's, x to the fourth, but I'm going to take 2 more. And now it's going to be x to the sixth. On the inside of that radical is going to be all the stuff I didn't circle. So that's going to be a 3x. And that would be my reduced radical form. Okay. Let's try one more. Okay, so the example 4, or this is really example 5, but this is going to be cube roots, so we have to be careful. We have to circle groups of 3. So whenever you look at these problems, always make sure you know what the radical that we're dealing with is. Now, there's no numbers on the outside that we have to worry about, so we're just going to make one big cube root, and we're going to multiply these together. So I'm going to have a 6x to the fourth, y to the third, times a 12x y to the third. So we want to multiply the two insides together. Now I am going to kind of combine these together. 6 times 12 is going to be a 72. You're welcome to use a calculator for that if you need to. X to the fourth times x is just x, to the fifth. And y to the third times y to the third is y to the sixth. Okay. Now, I am going to break this down into its smallest pieces. So I'm going to start with the 72, which I believe is 9 times 8, or 3 times 3, 4 times 2. And actually, I can break that 4 down even further to be a 2, 2, and a 2. Now, I also have 5 x's. So 1, 2, 3, 4, 5. And I have 6 y's, 2, 3, 4, 5, 6. And I am taking the cube root of this problem. So I'm looking for groups of 3. I have a group of 3 2's. I have a group of 3 x's. I have a group of 3 y's. And actually, I have a second group of 3 y's. So all of those things are the things that come out. So my answer, I would have a 2 on the outside, an x, 2 groups of y's, and then on the inside, I'm going to have 2 3's. Now, because there's 2 of these, I'm going to multiply them back together. That's going to give me a 9. And then I have 2 x's. I'm going to multiply them back together. That would be x squared. This would be my final answer for that radical. So for each of these problems on your assignment, I'm going to take a look. Do you know how to multiply these two radicals together? Can you at least get to this step? Then the second part is, can you actually reduce that radical into its lowest terms? Now, please be aware, notice when you're dealing with cube roots as opposed to square roots. So when you reduce, you know whether to use groups of 2 or groups of 3, or your perfect squares or perfect cubes. Okay? If you have any questions, please email me. Again, my success criteria, I want you to be able to reduce a radical expression involving the operation of multiplication.